Okay, we are going to start section 2 of chapter 6. I'm going to present my screen. Section 2 is exponential function. A function of the form fx is equal to b to the power of x, where b is positive and not equal to 1, is called an exponential function. The domain of the exponential function is all real numbers, that is from negative infinity to infinity, and the range is from 0 to infinity. That means we can calculate the function value for all real values of x, whatever be the value of x. So far as it's a real number, you can calculate value of fx and the answer will be always positive. Now here is the graph. If b is greater than 1, it is an increasing curve which is concave up, and y-intercept will be 0, 1. And if b is between 0 and 1, it is a decreasing graph. That's it. Now the important results. First result is limit x approaches infinity, b to the power of x is equal to infinity, or in other words, b to the power of infinity is equal to infinity. And it is limit x approaches infinity, b to the power of x is 0 if b is between 0 and 1. I repeat, limit x approaches infinity, b to the power of x is infinity if b is greater than 1, and it is equal to 0 if b is between 0 and 1. And sometimes we skip the limit. We say b to the infinity is infinity if b is greater than 1 and is equal to 0 if b lies between 0 and 1. And now let us look at one of the examples here. Yeah, here it is. One of the questions, number 24. Limit x approaches infinity, 1.001 to the power of x. Definitely that is 0 because the base is greater than 1. If the base is greater than 1 and b to the negative infinity is equal to 0. Limit x approaches infinity, e to the negative x square means e to the negative infinity, that is again 0. Number 28. Limit x approaches 2 minus. Limit x approaches 2 minus e to the power of 3 divided by 2 minus x. And in this case, it's a good idea to draw the graph of it, e to the power of 3 divided by 2 minus x. See, I will show you how to graph it. E to the power of 3 divided by 2 minus x. Here is the graph. So this is the approximate graph of that. And x approaches 2 minus means the value of x is less than 2. So x is somewhere here. So when x approaches 2, the whole expression or the y is approaching indefinitely up, meaning up to infinity. And e is actually 2.718. So that is greater than 1. So this is the graph. Okay, we'll go back to the theory. The irrational number e. Limit n approaches infinity, 1 plus 1 over n whole to the power of n is a real number that exists and is a real number. It is an irrational number which is approximately equal to 2.718. This number is represented by the letter E. So whenever you see the letter E, it is an irrational number approximately equal to 2.718, which is very similar to the irrational number pi, which is approximately 3.14. Fx is equal to, this is a natural exponential function. Fx is equal to limit n approaches infinity, 1 plus x over n whole to the power of n is denoted by e to the power of x, and this is called the natural exponential function. It can be shown that e to the x is equal to 1 plus x over 1 factorial plus x square over 2 factorial plus x cubed over 3 factorial, etc. It is an infinite series. You will see this series in chapter 11 later. Result number 2. Limit x approaches 0, e to the x minus 1 whole divided by x is equal to 1. E to the x minus 1 whole divided by x is equal to 1. Proof. I have given the proof here. Limit x approaches 0, e to the x minus 1 over x is equal to limit x approaches 0, e to the x is this infinite series. So 1 plus x over 1 factorial plus x square over 2 factorial plus x cubed over 3 factorial plus etc. minus 1. And now 1 cancels, and from the rest of the terms you pull out an x. So it becomes x times 1 over 1 factorial plus x over 2 factorial plus x square over 3 factorial, etc. And now substitute x is equal to 0. Sorry for that. Substitute x is equal to 0. So you get 1 over 1 factorial plus 0, 0, 0, etc. So the answer is 1. Result number 3. Limit x approaches infinity, e to the x is infinity since e is greater than 1. Or in other words, e to the infinity is infinity. Limit x approaches negative infinity, e to the x is 0. Limit x approaches infinity, e to the negative x is 0. These two are the same as e to the negative infinity. Result number 4. Yeah, here comes the calculus. Derivative of e to the x is e to the x itself. So this is the only function whose derivative is equal to the function itself. Proof. F prime x is equal to limit h approaches 0, f of x plus h minus fx whole divided by h. Or divided by h. That is equal to limit h approaches 0, e to the x is fx. So fx is e to the x. F of x plus h is e to the x plus h. And that is equal to e to the x times e to the h minus e to the x all over h. And now you may pull out e to the x. That becomes e to the x times e to the h minus 1 whole divided by h by factoring out e to the x, that is e to the x times limit h approaches 0, e to the h minus 1 over h, which is a 1. The whole thing is a 1. We have seen that. That is e to the x minus 1 times 1, which is equal to e to the x. Result 5, the same thing. Since the derivative of e to the x is e to the x, and the derivative of e to the x is e to the x plus c. And we have worked out number 2 up to 28. Okay. Now here says limit x approaches pi over 2 plus e to the tan x. So here is the graph of tan x, not e to the tan x. This is the graph of tan x. So tan x has a vertical asymptote at x is equal to pi over 2, and it goes to infinity from the left, go to negative infinity from the right. So from the graph, it is clear that limit x approaches x pi over 2 plus. Pi over 2 plus means x is more than pi over 2. So x is somewhere here. So y is going indefinitely down. So limit x approaches pi over 2, tan x is negative infinity. So limit x approaches pi over 2 plus e to the tan x is e to the negative infinity, which is 0. Now the remaining questions, just differentiate. And first one, I have worked out all the even numbered questions. So kr is equal to e to the r plus r to the c. So k prime r is equal to derivative of e to the x is e to the x. So derivative of e to the r with respect to r is e to the r, and here c is a constant. So you recall the power formula or power rule. Derivative of x to the n is nx to the n minus 1. So this one is the r to the c minus 1. So answer is e to the r plus c times r to the c minus 1. Number 34. Fx is y is equal to e to the x whole divided by 1 minus e to the x. You have to differentiate by using the power rule. So dy over dx, power rule is here. F over g prime is equal to denominator times derivative of the numerator minus numerator times derivative of the denominator, or divided by the square of the denominator. So this is 1 minus e to the x times the derivative of e to the x, which is e to the x, minus e to the numerator, e to the x times derivative of 1 is 0, 0 minus e to the x, whole divided by the square of the denominator, 1 minus e to the x, the whole square. Now you simplify this. You distribute e to the x here. E to the x times 1 is e to the x. E to the x times e to the x is e to the 2x, x plus x, e to the 2x. So that's minus e to the 2x. Their term is 0. And when you multiply these two, negative and negative makes a positive, e to the 2x. E to the 2x cancels. So the final answer is e to the x divided by 1 minus e to the x, the whole square. That is the answer. Number 36. Gx is e to the x square minus x. So you have to apply the chain rule. First, assume that this is a single expression, single letter. In that case, derivative of e to the u is e to the u itself. So derivative of e to the x square minus x is e to the x square minus x times, you take away this e and differentiate x square minus x, 2x minus 1. Derivative of x square is 2x, that of x is 1. So this is the chain rule. So derivative of e to the x is e to the x. So derivative of e to the x square minus x is x e to the x square minus x. Multiply that by the derivative of x square minus x. That is the answer. Number 38. Here again, you have to use the chain rule. Denominator times Derivative of the numerator, derivative of 4 is 0, that of t is 1. So t to the t times 1 minus numerator times 4 plus t times, you have to apply the product rule here. First function times the derivative of the second, that is t times e to the t, plus second function times the derivative of t, that is 1. And now from the numerator, there is a e to the t common. You pull out that e to the t times t minus 4 minus t times t plus 1. And now e to the t to the t the whole square is t square times e to the t times e to the t cancels. And now you have t minus 4t plus 4, here it is. Yeah, you are distributing this. You are distributing the 4t plus 4 plus t square plus t plus t. That whole divided by t square e to the t. Now you distribute the negative sign. T minus 4t minus 4 minus t square minus t whole divided by t square e to the t, and the t cancels. Final answer, you may pull out a negative sign, negative t square plus 4t, because negative sign is pulled out, plus 4. So negative t square plus 4t plus 4 whole divided by t square e to the t. Next, y is equal to t square e to the negative 1 over t. So dy over dx, you have to use the product rule. First function x square times the derivative of the second function, exponential function. Derivative is the same, so it is first step is e to the negative 1 over x. Now you have to apply the chain rule. Derivative of negative 1 over x is positive 1 over x square. Negative, two negatives makes a positive, and plus e to the negative 1 over x times 2x, that is equal to this x square cancels, and e to the negative 1 over x is common. E to the negative 1 over x times 1 plus 2x. Ft is equal to tangent of 1 plus e to the 2t. You are going to use the chain rule. So derivative of tan x is secant square x. So this is secant square of the whatever b is in the parenthesis. So that is secant square 1 plus e to the 2t. Multiply this by derivative of whatever is inside the bracket. Derivative of 1 is 0 plus e to the 2t times derivative of 2t, that is 2. So that is it. You may write one more step. The 2 comes in the front, 2 e to the 2t times secant square 1 plus e to the 2t. That is the answer. Number 44. Fz is equal to e to the z over z minus 1. Same procedure. First step, e to the z over z minus 1. Now you are differentiating the expression in the exponent. Quotient rule, c minus 1 times 1 minus c times 1 whole divided by c minus 1 the whole square. Now you distribute the negative, distribute that 1, you get e to the z over z minus 1 times z minus 1 minus z whole divided by z minus 1 the whole square. And final answer is 1 negative, this is negative 1 over z minus 1 the whole square times e to the z over z minus 1. That's it. Okay, another one. Y is equal to e to the sine 2x plus sine e to the 2x. First step, we are differentiating the first step. E to the 2 sine 2x times derivative of sine 2x is cos 2x times 2. Then sine, derivative of sine is cosine. So it is cosine e to the 2x. Now derivative of e to the 2x, that is e to the 2x times 2. So that is the answer. 48. Y is equal to square root of 1 plus x times e to the negative 2x. That is, now differentiate. First step is use the formula for square root of x. Derivative of square root of x is 1 over 2 times square root of x. So this becomes 1 over 2 times the whole thing. 1 over 2 times square root of 1 plus x e to the negative 2x. Now you have to differentiate whatever is under the radical sign. Derivative of 1 is 0 plus x times e to the negative 2x times negative 2 plus e to the negative 2x times 1. Or, yeah, now you have to simplify. That is, e to the negative 2x is a common factor here. Pull out e to the negative 2x, then there is a 1 minus 2x, and the denominator is the same. Okay, now you have to find the equation of the tangent line at this to that curve at the point 1e. When x is 1, y is e. So it is 1e. Y is equal to e to the x divided by x. So dy over dx y, because you are finding the slope of the tangent line. Slope of the tangent line is dy over dx at that point. So dy over dx is equal to x times derivative of the numerator, that is e to the x, plus e to the x times derivative of the denominator, that's a 1, whole divided by x square. E to the x is common factor, or you don't have to pull it out. You simply plug in x is equal to 1. X is 1. So it is 1 times e to the 1 plus e to the 1 whole divided by 1 square. So that is equal to e plus e, which is 2e. So that is the slope. And the equation of the line is y minus y1 is equal to m times x minus x1. x1 is 1, y1 is e. And so y minus e is equal to, slope is 2e, 2e times x minus 1. Now, you may leave it there, but usually we distribute it. So y minus e is equal to 2ex minus 2e. That's it. Then you add an e on both sides. So this minus 2e becomes minus 1e. Y is equal to 2ex minus e is the answer. Number 54. Same thing. You have to differentiate this by using the implicit differentiation. So the implicit differentiation is here. You differentiate with respect to x. First, product rule. First function, x times derivative of e to the y. Derivative of e to the y with respect to y is e to the y. But in this case, it is with respect to x. So x times e to the y times derivative of y, that is y prime, plus second function times derivative of x, that is e to the y times 1, plus now differentiate the second function, first function times the derivative of the second, y times e to the x, plus e to the x times y prime, and the right side is 0, derivative of 1 is 0. Now set x is equal to 0 and y is equal to 1, then you get x is 0, so first term is 0, y is 1, so this is e to the 1. Here y times 1 times e to the 0 plus e to the 0 times y prime, e to the 0 is 1. So you have e to the 1 is e, plus 1 times e to the 0, that's e to the 0 is 1, e to the 0 is 1, so you get e plus 1 plus y prime is equal to 0. Now you solve for y prime is equal to negative e minus 1, subtract e and subtract 1. Equation of the tangent line formula is y is equal to mx plus b. In this case, we use the slope intercept form because this is the y-intercept. X is equal to 0 means this is the intercept. You may use the other formula also. There's nothing wrong in it. So y is equal to mx plus b. That is y is equal to minus e minus 1 times x and plus b. The one is missing here. I'm sorry. There is a 1 here. So please correct it. Y is equal to mx plus b. M is negative e negative 1. So it is negative 1 negative e negative 1 plus 1 is there. So the answer here is, please correct that. The answer here is y is equal to m, that is negative e minus 1 x plus 1. So that is, oh, the caps lock was on. Negative e negative 1 times x plus 1. So that is the answer. 1 is missing there, so please correct it. Okay, so now question number 60. F 1000, meaning you differentiate this function 1000 times. What will be the answer? So that is the question. You don't have to differentiate 1000 times. You may differentiate 2 times or 3 times. And then there you see a pattern. And from the pattern, you can write the 1000. Okay, let us start with f prime x. F prime x is equal to negative x e to the negative x plus e to the negative x. So y double prime x is equal to x e to the negative x minus e to the negative x. Minus e to the negative x times 1 plus e to the negative x times negative 1. That is it. So when you simplify, you get x e to the negative x minus 2e to the negative x. Now differentiate that with respect to x. When you differentiate that with respect to x, you get f triple prime. Again, x times e to the negative x times negative 1. So negative x e to the negative x plus e to the negative x times 1 plus 2e to the, where is that? 2e to the negative x. So that becomes negative x e to the negative x plus 3e to the negative x. That is f triple prime. Differentiate once again, you get x e to the negative x minus e to the negative x minus 3e to the negative x, that is 3e to the negative x times negative 1 is equal to x e to the negative x minus 4e to the negative x. Now you look at the pattern. When you have a 1 here, there is a 1 in front of the e to the negative x. When you have a 2 here, that means if you differentiate 2 times, there is a 2 in front of this. When you have a differentiated 4 times, this is positive. 1 and 3 are positive, 2 and 4 are negative. That means the sign in front of the last term is negative if the number is even. 1000 is an even number, so you have to use the pattern for y double prime and y fourth power x e to the negative x minus 1000 e to the negative x. Okay, now integration. And this question is slightly misleading question because there is no x there. There is no x there means it's a constant. And the derivative of a constant is that constant times x. That's it. E is a constant. So e to the e dx is e times x. From negative 5 to 5, substitute the limit e times 5 minus negative 5. So that is 5 plus 5, which is 10. Next, x square e to the x cubed dx. You need a substitution. Let u is equal to x cubed. So differentiate both sides with respect to x. You get 3x square dx is equal to du. That is x square dx is equal to du over 3. Divide both sides by 3. So this expression becomes e to the negative u times du over 3. So 1/3 is a constant and the derivative of e to the u is e to the u. There is a plus c, and now replace u. U is x cubed. So the answer is 1/3 e to the x cubed plus c. Okay, next one, 88. 1 plus e to the x the whole square divided by e to the x. So you distribute the numerator. That means 1 plus e to the x the whole square is 1 plus e to the x times e to the x. You FOIL. Once you FOIL, you get FOIL and combine like terms. You get 1 plus 2e to the x plus e to the 2x all divided by e to the x. And so e to the negative x, and you are distributing that e to the x. 1 over e to the x is the same as e to the negative x. Second term, e to the x cancels. So that's a plus 2. Third term, e to the 2x divided by e to the x is e to the 2x minus x, which is e to the 1x. Now to integrate, so in this case, e to the negative x divided by negative 1, because it is a reverse process of differentiation. If you differentiate e to the negative x, you write e to the negative x times negative 1. So this is a reverse process, so you have to divide by negative 1. 2 is a constant, 2 times x, then integral of e to the x is e to the x plus c, and that's it. So this negative 1 may be written in the front, so it becomes negative e to the negative x plus 2x plus e to the x. Okay. Next, number 90. Here again, you do a substitution. U is equal to e to the x, 4 plus e to the x. U is 4 plus e to the e to the x. Differentiate both sides with respect to x. We get e to the x dx is equal to du. So replace e to the x dx by du. 4 plus e to the x is u. So it is u to the 5 du. And use the power rule, it u to the x, 6 over 6, x to the n plus 1 over n plus 1 formula, u to the 6 over 6 plus c, and u is 4 plus e to the x. So 4 plus e to the x, 4 to the 6 divided by 6 plus c. Last question. This is question number 92. E to the sine theta times cos theta. So you substitute u is equal to sine theta. So sine theta is u. When you differentiate, you get du over d theta is cos theta. So cos theta d theta is du. So this becomes e to the u du, e to the u, and the derivative is e to the u itself. So e to the u plus c, that is e to the sine theta, because u is sine theta. So e to the sine theta plus c. Okay, please practice this and then work out the homework assignment problems.